Okay, so yesterday we left off, we were like almost all the way done, the first survival guided notes, and we ended talking about like terms. Okay, so remember, like terms are terms that look similar. They have the same letter, and if there's a number like an exponent, the exponent has to be the same as well. So 3x and 2x. That's an example of like terms. You already wrote some examples down yesterday. I just put some other ones up here. There's another one, 2y, negative 8y. So when you think like terms, if things are alike, they have to look similar. So what do you think the opposite of like terms is? Non-like terms. So non-like terms, and I think, let's see, do you guys already have that written down, what non-like terms are?
No.
Okay, so that part you'll have to write down.
I didn't deal with a few problems.
After that on the blank line. Non-like terms are, and let me try to shorten this up like I did the other one. So hold on one second. I'm just going to say non-like terms, and we'll shorten it to, non-like terms have different variables or different exponents if they are attached to the variable. So non-like terms are either going to have different letters or different exponents that are attached to the letters. Right, so let's write down a few examples of non-like terms.
Like 4y
All right, let's start with 4y.
plus like 6x.
All right, and 6x. Those are non-like terms. One of them has an x. One of them has a y. Could somebody give me another term different than using like an x and a y? Sam?
12a.
All right, 12a
6b.
and 6b. Okay, so those are non-like terms because they have different letters.
3x to the second power and 5x.
Okay, perfect. So 3x to the second power and 5x cubed. So they don't have different variables, but they do have different exponents that are attached to the variable. Okay, one's a 2, one's squared, one's cubed. So those are examples of non-like terms. Right, that's good. Those are good examples. Does anyone have any other questions or, yeah?
Do you have to put and inside? Like and. So could I do like 3 plus, and then 3b plus 3a?
So what I'm just showing you here is just here's one term and here's another term.
Okay.
So I'm just showing you two different terms. I'm not writing an expression with addition, subtraction, or like that kind of thing. I'm just saying here's one term, here's another term, and they're not like terms.
Okay.
Yeah. Okay. Any other questions about what a non-like term is? Okay. And it's important to know what non-like terms are and like terms when we talk about combining them together. And you did some of that on that 10 questions I just gave you. Now, this number here, the 3, or that number there, the 5, or in this case the 6 or the 4, that number has a special name. Does anybody know what you call the number?
Coefficient?
Yep, that's called a coefficient. So I think you guys have a blank line for that, where it says 7 is referred to as the, and you want to fill in the word coefficient. Coefficient just means that it's a number in front of a letter. So if I wrote something like this, 12x. What would be the coefficient? 12. Yep. It's the number that's in front. All right. And what's the last thing? Okay, so the last thing says only like terms can be added and subtracted. So let's take some like terms, and this is where the homework started at question 10, and I said you could stop there because we didn't do it. Now we're going to try some of them. Let's take 3x and 2x. Have a good day. Thank you. So let's take 3x and 2x, and let's add them. When you combine like terms, the letter stays the same. The only thing you have to add are the numbers in front, or subtract if it was subtraction.
So basically, no notation.
Yep. So think of it, if you had 3 x's and you put 2 more x's with it, how many x's would you have altogether? 5 x's. Yep. Let's do the same thing, but let's do subtraction. First of all, I asked myself, okay, are they like terms? X and x? Yep, they are like terms, so they can be subtracted. If you have 3 x's and you take away 2 of them, how many would that leave you with? How many x's? One, right? Would leave you with just one of the x's. Or if you write x, that means the same thing. So 3x, take away 2x, you leave the letter the same, and you just subtract 3 minus 2. Let's try 4x squared and 3x squared. And let's add them. First of all, can we add them? Are they like terms? Yeah, they are like terms, so they can be combined. Remember, you keep the letter with the exponent the same. So in this case, what's my letter with the exponent? Which variable? X squared. So that's my letter with the exponent this time. So that part stays the same. And now all I have to do is add the 2 numbers that are in front. 7. So the answer to that one is 7x squared. Okay, let's try one a little bit different. Let's try something like 2x plus 3 times x plus 4. What property is going to be in this one that we talked about yesterday? Distributive. I'm going to have to do something like that. When I distribute that 3, does it affect the 2x? No, because that's before it. So nothing happens to that. But now let's multiply this out. What's 3 times x?
3x.
Do just 3x. Yep. Positive 3x. And then what's 3 times 4?
12.
12. Now, if we look at that, it's kind of like what we had up there. Are there any like terms that you could combine together there? 2x and what else?
3x.
3x. How about the 12? No, that's not a like term. It would have to have an x next to it to be a like term. So the 12 is just going to stay the way it is. Then 2x plus 3x, we just did that. That's 5x. Okay, so that's combining like terms. And that's what questions 10, 11, 12, and 13 were on the homework last night.
Is that solved?
That's as far as you can go. Yep. You cannot solve it for x. The only time you can solve for x is if they put an equal sign in there and then put a number on the other side like this.
Okay.
Now we could do some stuff to solve for x.
So right now it's wrong.
But right now, that, no, it's not wrong.
No,
That's just as simplified as you can go.
Yeah, that's
Yep. Now, how about if I gave you this? A plus 3B. How would you combine those together?
I mixed.
They're not like terms.
They're not like terms. And since they're not like terms,
They can't be added or subtracted.
they can't be added or subtracted. Okay, so if they're not like terms, you can't add or subtract them. How about if I did 2A plus 3A squared? Are those like terms?
Yeah.
Mm-hmm.
Almost.
Oh no.
No, those ones squared.
Well, one of them is squared and one of them isn't. So if they're not the same letter and the same power, then they're not like terms. Okay, so no like terms there. And if I asked you to add them together, you just write down you can't. They can't be added together. Any questions on that? All right, so the last part, let me just give you guys the answers to the homework. So if you want to double check what you got, you can take your Chromebook out. Check that. Generally what I'll have you do is if you do your homework on the Chromebook, you can bring it up and show me. And then when we're done going over homework, you can put your Chromebook away when you start the lesson. All right, so let me go through some of the answers. And then if there's any questions, we will have time to probably do a couple. So for number one, actually, I'll ask you guys to tell me what you got. Sam, what did you get for number one?
3.
3. Yep, 3 is correct. Number 2, how about Eli? What did you get for number 2?
7 R equals 9.
Yeah, when you plug 9 in for R, what did you get?
63.
63. Yep. So remember, evaluate means they're looking for an answer. Looks like number 3. I'm not sure you could actually do that one because they didn't give you a number to plug in. So yeah, that one was a little weird.
I just put a random number.
Yeah. So sorry about that. So don't worry about number 3. Yeah. Number 4. It says the cost in cents of P pounds of apples. How would you write an expression for that? I think we did one yesterday, maybe with
It's
tomatoes.
the same thing.
It's like very similar. Yeah.
Is it P equals 39? No, not equals. P times 39.
Exactly. It's P times 39. If you did 39 times P, that's the same thing. But yep, you did have to use multiplication.
I did X equals 39 here.
Yeah, that's fine. 39p is what they were looking for. Yeah. The number 5. 5 books less than the number of books on the shelf. You could also say like 5 fewer, but it's 5 books less than the number of books on the shelf. You gotta be careful with this one, Marie.
E minus 5.
Yes, this is the one where you do have to switch the order. It's B, take away 5. Yep. All right. How about number 5? Did anybody think they get that one? Lily?
4.
Yep, that's going to be 4. Number 6, I know it's a little blurry, but that says 5 squared. Anyone think they got number 6? Sam?
75.
That looks like 75. Yep. Number 7, I'm going to need a calculator for that one.
324.
Yep.
You got 324, so that's going to be 18
18 squared, right?
times 18. Yep, so that's 324. And number 8, simplify with distributive property. Okay, anyone think they got that one? Number 8. Yeah, everyone?
48.
48, because you do 10 plus, if you did 16 times 3 is 48, yep. Or if you did distributive property, it's 30 plus 18, 48, yep. And the last one that I asked you guys to do, number 9. Anybody get that one?
4.
Yep, really.
24m minus 20.
24m minus 20. I think that looks good. Now, can you combine those together?
No.
Nope, because one of them has an m and one of them does not.
The m.
Can I do some?
Normally I'd let you do it, but we gotta pause because we have to head down to the assembly in a minute. So if you did not finish, let's see, questions 10, 11, 12, and 13, just make sure you finish those for next time, and I'll check what you did on those. We'll go over them, and then we'll do the survival guide part 2 next academic Monday.